Hello everyone, today we're going to be walking through a few of your problems on this worksheet, investigating graphs of quadratic functions. Okay. So what is a quadratic function? What does the graph of one look like? And some key terms that you should know when graphing it. So today we're going to be kind of graphing these by hand the long way and learning a lot of vocabulary. So what's a vertex, your intercepts, a line of symmetry, a max or min, and increasing and decreasing intervals. And we're going to just take our time on these, labeling all of this information so that you are familiar with all of these terms. Okay, so first I'm actually going to start on the second page because this one is the basic graph of a quadratic equation. So where we're headed in the next few weeks is graphing any type of quadratic equation in the form y equals ax squared plus bx plus c. So this here, y equals x squared, is our basic what's called parent graph. Okay. So let's go ahead and see what this looks like when we plug in values. So they want us to make a complete graph or table of values and then label the following key points accurately. So you could use Desmos, graphing calculators, and so forth, but if you have no technology, essentially you're just plugging in these x values and finding out what the y values are. So when I plug in -4 in for x, remember -4 squared is going to be a positive 16. When I plug in -3 squared is going to give me 9, and so forth. -2 squared would give me 4. -1 squared is 1, 0 squared is 0, 1 squared, is still 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, so when we go ahead and plot these points, 0, 0, because -4, 16 is not going to fit, -3, 9, 6, 7, 8, 9, right here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and again the other 2 points won't fit. So I'm going to attempt to draw a nice curve passing through all of those points. Okay. Now this shape, the graph of a quadratic function, is called a parabola. Now, some of you may have already known that. So where we're headed, like I said, in the next few weeks is looking in depth at graphs of parabolas and some key points and attributes of them. So first thing we need to know is a vertex. Okay, the vertex is the lowest or highest point. So we're going to label that on our graph. Okay, so this point right here is the vertex, and that coordinate is 0, 0. Okay. The x-intercepts, we actually only have one x-intercept here. Okay, so the x-intercept, go ahead and label this here, is also 0, 0, and that happens to be the y-intercept also. Okay, kind of a boring one, but that's typically not the case unless you have the vertex on the origin. Okay, so we've got the x and y intercepts labeled. The line of symmetry, now that's just that imaginary line that you can draw through a figure that cuts the shape into two symmetrical parts. So you can see if I draw a line on the y-axis, the line of symmetry is actually the y-axis, but we write it as a vertical line, which is x equals 0. This is our line of symmetry. Okay. Now, the next part, is there a maximum or minimum value? So you're going to see two types of parabolas. We can have parabolas that open up or parabolas that open down. If we have a parabola that opens up, this is a minimum value. Whoops. And if the parabola is opening downward, of course, this is a maximum value. So it's basically the lowest most y value or the highest most y value. That's a min versus a max. So of course, since this parabola is opening upward, the vertex is a minimum, okay? So if we asked you, you know, what the graph had, you just make sure you know how to find whether it's a minimum or a maximum. Okay, now the last part, increasing and decreasing. So in integrated 1, you guys learned about graphs that increased a positive slope or decreased a negative slope. Well, parabolas are doing both. We are decreasing for this portion of the graph until we hit the origin, and then when we hit that minimum value, we start to increase. So on your homework today, I want you to actually take 2 different colors and label those points. So try to find a different color here. All right, so this portion right here. Hi, I'm making a video right now. So this portion right here is decreasing. Whereas the portion on the right, we start to increase. Okay, so that is numbers 8 through 10 done for you. Again, our very basic parent graph. Let's do another example. It's a little bit more interesting. We'll start from the first page. So we're going to be looking at this equation right here. And typically, we're going to have some different techniques to graph this quadratic equation, but for today's purpose, we want to kind of look at plugging in values and completing this table of values. So you can pull it up on Desmos, or essentially, again, like if you don't have a graphing utility to do this, make sure you do know how to plug in points. So I'm going to start with actually 0, 0. If you plug in 0 for y, sorry, not 0, 0. Plug in 0 for x. We're going to get 0 squared plus 6 times 0 plus 8. Therefore, the y value is going to be 8. And you have to do that 8 more times for each x value. It's really nice to be able to plug it in with a graphing calculator sometimes. So if I plug in 1, we get 1 squared plus 6 times 1 plus 8. 1 plus 6 plus 8 is going to be 15. So that's a y value of 15, and so forth. So I've already filled these in ahead of time to speed this up. We would have to do that so many more times. Okay, so negative 4 ended up being a 0. Negative 3 is a negative 1. Negative 2 is 0. Negative 1 is 3. 2 is 24. 3 is 35. And 4 is 48. Okay, so after plotting these points, let's go ahead and plot these. We've got negative 4, 0. Whoops. Negative 3, negative 1. Negative 2, 0. Negative 1, 3. 0, 8. And notice the rest will not fit on our graph. But as you can see, hopefully you see that these 2 points are symmetrical. So that means this parabola is coming down, hitting a minimum value, and it has to come back up. So we can use this idea of symmetry. Okay, here's my axis or line of symmetry to find matching points on the other side. So that means I've got to have a point 2 units on the other side here, and 3 units on the other side of that line to match there. Okay, so filling in those points, we get a nice sketch of this parabola. Okay, now at the same time, you can go ahead and realize this portion of the graph is decreasing down to the vertex and increasing after the vertex. This is my increasing value or portion of the graph, and the portion of the graph that's decreasing is right here. Okay, so again, we're just getting used to learning these new terms, labeling this parabola with all these key points. So coming back to our list, we also need to label the vertex. In this case, it's not the origin this time. We've got the vertex is -3, -1. and that's also a minimum value. Okay. The x-intercepts is where the graph will intersect the x-axis. So that's going to be these 2 points right here. So remember back when you find x and y intercepts, that's where your y value is equal to 0. You can also see that in the table, which is quite important. So our x-intercepts is -4, 0 and -2, 0. And again, where we plot those is where it's crossing the x-axis. So x-intercept is at -4, 0, x-intercept at -2, 0. Okay, the y-intercept is where the graph intersects the y-axis, which would be this point right here. Which is at 0, 8. So once again, hopefully you remember from IM1, y-intercept is found from plugging in 0 for x. So you can see that in the table as well. That's the y-intercept. Okay. Line of symmetry we already sketched, but we should name it on our graph. Okay. So again, this is my line of symmetry. It's going through the x-coordinate of 3. So it's x equals, -3. That's my line of symmetry. Okay. We already labeled our minimum value since it's opening up. Oh, and we already labeled our increasing and decreasing portions of the graph. Okay, so like I said, this is just an intro to graphing quadratic functions, a lot of new vocab and understanding that when you do graph a quadratic function, that you're going to get that parabola shape, either facing up or down, and we're going to be focusing a lot on these graphs the next few weeks. So on your own, I want you to graph the other two that we haven't finished, and again, the solutions are posted online. So good luck with that, and we will see you